Okay, hi everybody. I'm going to give hopefully a short talk. Give 15 minutes, as Glenn says. Bit of a challenge. I'm going to talk about IoT security. So, slightly different. I mean, mostly when you hear about security, it's some sort of hyped news story. What I want to do is try and share some of my experience in dealing with companies to actually get down to the root of it. Why does it happen? Well, why do we see this? So I'm going to start off with, well, what is IoT? And it's actually quite a difficult question to answer. Everybody has their own view of what IoT is. I think one of the sort of most recent definitions is it's a real or virtual thing that can be identified and is connected to a network. So we're off to a pretty broad definition for a start. So of course you've got the things like Alexa, coming in the homes. You're seeing a lot, as I mentioned, you're seeing a lot more consumer-based IoT now because the pricing point's getting affordable, the sort of features getting good. So what about white goods? You might think at the moment there's many IoT white goods, but actually in about 2 years' time, most of your white goods are going to be IoT connected. A lot of the major manufacturers have now said they're going to put it across their range, even from the very, very low end stuff to the high end. And there's a lot of benefits for it, because going back to Glenn's talk again, if the manufacturers can measure how systems are being used, they get the benefit, but they can also feed that benefit back to you as a consumer. For instance, if you're a light user of the machine, they can give you a longer warranty. Okay, so we've got connected white goods. Collecting data, it's another thing maybe privacy will need to deal with later. So scaling a bit bigger, what about a car? You can consider that an IoT device. It's a real thing, it's identifiable, and it can be connected to a network. All your future cars are going to be connected to networks. They're all going to be connected via 3G, 4G, mobile, and they're incredibly complex machines. They're essentially a very large computer on wheels. Scaling up a bit further, what about an entire city? Smart cities. Again, you can sort of consider that as almost a single IoT entity as well as a conglomeration of many little ones. And it goes beyond that, of course. We have our internet-connected talking fishes. We have an internet-connected toilet, which I think you might have missed that trick in your connected bathroom. It's a nice Japanese invention. Some of them are crazy, some of them won't go anywhere, some of them will have real value. I mean, Fitbits now, yeah, popular things. So, you see a lot of IoT scare stories in the news. And one of the things I want to really get through is it all hype? Well, hopefully at the end of this, you'll realize there are some real security issues with these devices. There is a real problem there. So we start with what is security. So this is just a dictionary definition. So freedom from danger or harm, well-founded confidence or protection and defense. But of course the question is, protection and defense for what? And this is another thing we have to deal with manufacturers in security is they have to identify first what they're trying to protect. And that's often quite, it's more difficult than you would think. Obviously, if you've got something like a vehicle, safety is a big issue. But in other cases, it's a lot of intangible things like the company's reputation. So, why is security hard in the IoT? Well, it really comes down to complexity. So, we have these systems. An IoT system is now, you have a device which is a cyber-physical system, as they call it, it usually has some interface with the real world, so either sensing or actually causing an effect on the real world. You then have a communications network. Might go to a gateway device, another device which handles all the small sensors. You then probably have another communications network to a server, or a remote cloud server somewhere. And all of these pieces are complex to maintain. They take a lot of skills, each component, but put them all together, and even as a system, they're really difficult to work with. You need a whole range of skills, and particularly smaller companies just can't afford to keep that level of skill and keep those people employed and active, really. But there's other reasons too. So if we look just at the device side, we spend a lot of time looking at devices. Just got a while in a second, but physical access. So in your traditional IT security, your server is locked away in a building, somewhere far away. Some of them are stored in like nuclear bunkers. You're not going to get at them, they're physically protected. But you suddenly have an IoT device and it's in your hand. You know, you can look at it, you can see how it works, you can reverse engineer it, you can try and misuse it if you like. It's all there for you to play with. The devices tend to be, particularly, to get the cost scalable, they're not very capable. They don't do a lot. So they tend to have a very low-end CPU that runs slowly, and it's just good enough to do the job that the device was designed for. And a lot of IoT devices are single purpose, so they don't have a lot of memory, and that impacts things like being able to update them. So if somebody finds the software in those devices has a problem, often they can't be updated, or they just have to be left in a vulnerable state. They may have very slow communications. So there may be very low power devices that run on batteries. So waking them up to actually do a software update or a fix to them might use up a lot of the battery. And again, that has impacts on, even on consumer devices. You wouldn't want your battery-operated devices to fail. You don't have to keep replacing the batteries every couple of months. So it's a difficult balance, really. Security is always a compromise. The other problem we have is that these systems are very diverse. As I said, there's different communications mechanisms, there's different CPUs, there's different ways that these devices all talk together. So there's no one-size-fits-all security solution for these. It really starts to get complex. Okay, so why do we have all these insecure devices at the moment? So if we skip the skills problem, which has a lot to do about it, a lot of it comes down to perspective. And actually, a lot of it is rooted in human psychology. So it all depends how you look at stuff. So if we take the example of a car, well, nice and simple. Everybody knows what a car is. So as a consumer, it's something that takes you from A to B. You trust that it will take you there safely. Yep, I know. Fine. Engineering? Well, it's not just a car. It's a complex system full of mechanical bits, electrical bits, computers. So the next generation of cars coming out have roughly 200 computers in them. So very, very sophisticated devices on wheels, traveling at 80 miles an hour. The other thing is, from an engineer's point of view, when they're developing this car, they look at the functional side of things. They have been told, right, we have a vehicle, we want it to go to A to B safely. And that's what they concentrate their time on, to get it to work functionally. And engineers love building things, solving problems, and what comes out is indeed usually a car that will go from A to B safely. But of course what they're not thinking about is different view. The view an attacker, or take a thief for instance, might have on a vehicle is completely opposite. They're not looking at how can that car function, or how can any device do its job. But how can we break it? How can we misuse it, stop it doing its job? In fact, a lot of the cleverest ways of doing it basically turn things on their heads. So they use a lot of the features in the device to attack the device itself. So a good example in the automotive world is you've got your key fob to open your car, which is a radio control. Great. Very nice and convenient for the user. The attackers then turn that as an attack mechanism where they block the radio, wait for the person to walk away, replay it, and while you're going away thinking you've locked your car, they can just open it. So, and the device to do it, for your car that costs tens of thousands of pounds, their device costs about £5. So, of course, not all attackers are the same. So, take a terrorist, for instance. Cars aren't just there to be broken into. They're then a potential weapon. So, not only do we need to worry about the things that we need to protect on the vehicle, who is going to protect them, but also what their motivation is. Before you can think about how to protect a device, you need to know who's going to attack it and why are they going to attack it. And you can see it starts getting really complex. It's very specific to each product, and it takes a lot of analysis and a lot of trying to put yourself in somebody else's shoes to look at the problem. It's difficult, and it doesn't often happen. So what's the impact of all this? Well, you've all seen, let's say, the news stories about IoT devices getting, hacked into, broken. Take one device, for instance. Yeah, could be anything. Just pick the router here, but could be anything. Could be your smart kettle, smart fridge, your washing machine, who knows. As a single attack, yeah, okay, you can target an individual. You can get a lot of information out of these devices, even the ones which are supposedly quite secure, because all devices leak information. For instance, when your Wi-Fi is on and active, somebody outside your house could tell there's somebody in the house, they're doing something. So that's some information that's being leaked. But the damage is limited. And actually your chances of getting targeted, unless it allows something like a way of getting your credit cards or something like that, the chance of getting targeted are fairly slim, to be honest. There's easier ways to steal money from people. But what if you start looking at the bigger picture? And again, this is what a lot of manufacturers don't do. And human psychology, again, you concentrate on your device, single device, how it works, how it does it, how does it do the job it's supposed to do. But you don't start thinking, well, we don't just have one of these devices. Whenever they go out and get connected on the internet, there's going to be thousands of them. In some cases, millions of devices. And not only that, the devices are all the same. So if I, as an attacker, can break one device, and they haven't properly protected it and made each one different in some way, I can attack all of them at the same time. So now I'm not just getting into one person's house, I'm now misusing them to perform pretty serious damage. So the amount of, for instance, take Wi-Fi routers, the amount of network traffic I could generate from even 1,000 routers is enough to take a small company down. I get a million of these. I could take a very large company down, and even close to a country down with them. And it happened recently. Or what happens if we look at being able to disable even 1% of vehicles, for instance. So again, every vehicle's the same. If you haven't differentiated them, attack one, you can attack lots of them. You can gridlock a city with, how many models a car? How many active cars? Very few. Or we've all seen the WannaCry ransomware stuff recently. Okay, so look at the damage that did on PCs. Quite small deployments. But imagine if you have a worm that can jump between millions of devices. Now imagine instead of just the computers that manage the admin in hospitals, imagine the computers that run things like the medical instruments. What if it got through those, propagated? So there are real potential problems. But it's not all complete doom and gloom. What we've noticed as a company, which is really good, a couple of years ago, probably 3 or 4 years ago, we'd spend a lot of our time firefighting for companies. They'd basically come to us and say, our device, whatever it is, has been hacked and exposed on the news or a hacking conference. And we go, right, okay. Well, I'm afraid, you haven't designed it with security in mind. It's going to be really hard to fix. We can sort of put a sticking plaster over it, but it's often not much we can do. Well, nowadays, we're starting to get companies, a lot of large companies mainly, coming to us and saying, we're going to be producing a device, a car, or anything else, next year, or a couple of years' time. We're starting the design cycle, and we want to build security in during the design, which is absolutely the right time to do. If you don't put it in at the design time, you can't really retrofit security. So that's what we're seeing. We're also seeing the things like semiconductor manufacturers are now producing chips with much better security in them, features that help us to secure the systems. Our communications protocols are getting better. They're getting a lot more scrutiny from university groups who look at them and try to break them. So we know everything is improving, but it is going to take time to get there. And companies still need to realise in a lot of cases, that they need to design it in right at the start. So that's a hopefully, quick overview of security, why it happens, and hopefully what's happening with it. Thank you.